Hi and welcome to another video. This time around I'm looking for a graphics card for external GPU test for my old Apex modding laptop and of course for the new Apex 15 Max modding laptop. So I can test out how it performs with an external GPU connected to the M.2 slot, which got 4-lane PCIe 3 and 4-lane PCIe 4 connection. I picked a GPU which is roughly as fast as an RTX 3070 mobile. This one is an RTX 2070 Super from Gainward, a Phantom GS model. It's a rather nice GPU, but it got a problem because according to the previous owner it's broken. So today in this video I want to try to fix this one. It's rather unusual for my channel, at least at this point. Yeah, so first things first, we need to measure some basic stuff before we can actually check if this one is really broken. The previous owner said there's no image, so there could be anything up with this GPU. So all you need is a multimeter in the resistance mode. But before I start, I want to get out a short disclaimer. I'm no expert for repairing graphics cards by any means. I'm still a beginner. Yeah, I try to learn from the best. There's a lot of graphics card repair channels on YouTube, like QuizFix Germany and Texametry. So when you want to learn something, then you should visit their channels. And my channel is more or less for entertainment purposes. I will not do stupid things like baking this GPU, because baking is bad. I try to tackle this topic from a beginner's perspective, so maybe you can at least diagnose your GPU yourself. And yeah, so let's begin with that first. All you need to do is to get your black line, the ground one, attach it to the PCI slot. This is usually connected to the ground layer of the PCB. And then you can check some of the PCI slot pads. Now the first ones down here are 12 volts. None of them should be shorted, by the way. So those two 12 volts. This looks totally fine. From this notch on, the fourth pin from the right, so 1, 2, 3, 4, is 3.3 volts from the mainboard. Yeah, this is fine too. And now I should switch to the diode mode and check the third and fourth pin on the long slot. This is the reference clock, and it should be roughly the same on the third and fourth one. So when those values are way off, the GPU is dead in most cases. Switch back to resistance mode, not resistant mode, and now check the high power 12 volt inputs. So those shouldn't be shorted. Of course, one of those lines is ground, so yeah, you will see some 0 ohms there. But the other ones, which are far away from the notch here, are 12 volts. Some of them are some signal pins. I think this one is one, I guess. This one, not sure. But none of these should be short. So this one looks totally fine. And because we got no short from the outside connections, those are the basic ones I should just showed you. This GPU is safe to plug because there's no short. So we can put it into our test bench and try to boot it up and see if there's an image or not. Okay, well, this is my new test bench. This is an B550 Steel Legend from ASRock with a 5600G from AMD. Only 60 gigabytes of RAM. Maybe I will improve on that later. It's clocked to 3600 CL18. Yeah, and I saw this mainboard on eBay, and I really thought I got to get this one because my old test bench was really old, and I wasn't able to test PCI 4.0 features with my old test bench. Yeah, and let's go. Okay, I actually did not attach any HDMI cable. Nice. What an idiot. Yeah, and we got an image. Unfortunately, it's not a clear image thanks to the stupid capture card. It's not a quality one. Okay, as you can see, we got an image, but this image is not from the dedicated GPU. It's from the iGPU because I connected it to the mainboard. And I opened the device manager, and as you already can see, the RTX 2070 Super, oops, wrong one. The RTX 2070 Super got an error. It got a code 43 error code. Code 43 means the GPU is initialized, it's working, but it's not in a fully working state. So next up would be a memory test for the video memory installed on the GPU. Yeah, and from now on things became very chaotic. Well, I booted up the diagnostic software, which is on an external USB device, which is called Nvidia Mods. And yeah, all the testing I tried didn't work out, even on another graphics card, an GTX 1070. Well, it turns out my new mainboard requires some slightly different commands, so the footage I got is very confusing for you, so I just skip it, come to the result straight away. I will blend in the commands I used, and I will blend also the commands which I should have used, and you will also see me using those commands live in a real diagnostic software after my repair attempt. So stay tuned and let's continue. Yeah, so this is the result I got yesterday. So this is the same chip as you can see, TU104. I used 20 megabytes of buffer size, and I got some errors on the last chip, D1, which I will show you later which one it is, how you can find it out. And I had a second look on the GPU from the outside, and I noticed it before, but I didn't think it was too dramatic. But now I think differently. So what you can see here, the GPU's PCB is slightly bent. You can actually see it quite good in the video footage. So you see the line of the heatsink here, which is straight, and the PCB is starting to bend from like here and gets more extreme from around here. And I noticed that I can, with some slight squish, move the whole PCB here. So what my guess is, why this GPU wasn't able to output an image, the seller said. So when it arrived here, it was outputting an image, but it crashed after some minutes. So it's pretty obvious that this band maybe was causing this, because this cooler is quite heavy and the GPU was mounted horizontally in the computer. It was fixed on the slot and on the PCI slot. But all the other components here started to pull on the PCB. When I do this, you can see it wiggles around. And of course, this one moves a lot, and this side does not move a lot because it's fixed to the slot. So in the end, we got a lot of mechanical stress on this area. And guess what? The video memory chip which is broken is on this side. Okay, so what's next? Well, let's disassemble this graphics card and take a look at the broken video memory chip. Let's take a look at the PCB as a whole, and let's try to find out what else might be wrong. And if I can't find anything, I would desolder the broken memory chip and then see if it's fixed or not. all of those screws are loose. Even those ones. So the stiffening effect of the back cover had no effect at all. Which explains why the card was so much bent. And because of this, it's no wonder that we might got some damaged solder joints underneath the video memory chips, or maybe even the GPU. It's not as bad as it was in the PCI slot, but you can tell it's far from straight. But just sitting there, not being straight, is not problematic. It's the movement. Continuous movement because of heat cycles, transportation of the desktop computer. Doesn't matter, it stresses the PCB and the solder joints. Okay, finally, this is an RTX 2070 Super by Gainward, the Phantom GS version. GS stands for Golden Sample, so we got a hand-selected GPU on here. It got a different V-BIOS with little higher clocks, not by much, but yeah, it's a nice extra. Okay, so let's continue with some measurements. Okay, let's get a good ground connection. I could also use the pads, but I can slip, you know, and those tips are very, very sharp. So I use the slot metal, that's fine. So this fuse is fine. There's continuity. And this one is, oh, it's fine too, okay. I thought it's blown for a second. And this one is fine. I will blend in a little table of some resistance values, which you should expect for an RTX 20 card. I can check the coil on this side. It's 5 kilo ohms. So I don't want to see any short here. Oh, I actually see nothing. Bad contact? Yeah. 6.5 ohms. This is very low, but that could be the PEX rail, which would be normal. Right around 5 kilo ohms again. 8 or so. Let's see, we got this one here. 200. It's a lot. Yeah, 200. It's pretty much the same. And now to the critical part. Well, in the first test, when I was not recording because my capture card was broken, the results showed a defective D1 memory chip. And on Nvidia cards, you must know that bank A are those two chips, bank B are those two, C and D. And the first chip is always the 1 and the second the 0. So we got A1, A0, B1, B0, C1, C0, D1, which is the defective one, and D0. So according to the results, this one is defective. We should desolder it. And we should, because the PCB was bent, we should at least reflow this chip and this chip to get rid of possible other broken solder joints straight away before other errors can appear. Okay, so as you might have seen, I've added a thermal probe. I protected the GPU at least to the half on the top side From the heat I will apply to this chip, so it cannot flow underneath the GPU that easily, and stress it from the side. I also added some Captain tape, that's the name of this yellow stuff, heat resistant tape. Also added it underneath the GPU, so it does not receive the heat from the cooking plate from the bottom, not too much at least. I'm not sure if this is good or if it's bad, if it just collects more heat underneath the tape. I'm not sure, so please don't quote me on that, but my feeling tells me that this might help to reduce the thermal stress on a GPU. Oh yeah, you might ask yourself why I put it on a cooking plate initially. Well, this GPU got a PCB with a lot of copper, so you really want to preheat the PCB to make it so warm that it can accept the additional heat from the soldering station easier, so it does melt quick and does not do any damage over time to the components around. So I will preheat it to 150 degrees C. We'll blend in the Fahrenheit. The solder on here is lead free and it should melt at 230 degrees Celsius. So I need to add just a little more heat, like 80 degrees C, which is not too much, and it should take no time to desolder this one. Okay, now we are approaching 150 degrees C. We are not there yet, of course, but it's time to start heating up the area. And now the temperature on the probe will skyrocket. Let's apply some flux. Pretty nasty stuff, so you should use a fume extractor, which I totally forgot, of course, as always. Already loose. Okay, it's crazy fast. Oh no. Do you remember what I said about the caps? Yeah, well. Good job. Ah, shit. Again, it was the pliers. The pliers killed me. Let's fix that. yeah, the pads look good. No rip pads, as you can see. So that's a good sign. They look quite clean. I'm not sure if some of them might be corroded. So when there's a pad corroded, then you got a problem that the solder joint does not want to stick to it properly. It just sits on it, and it might have a contact. The signal might come to the chip, or it might not. So that could be another reason for partial defects. And you won't believe how often you will find corroded pads, especially on graphics cards. So not sure what's up with that, but they look good, to be honest. Well, to check if some pads are actually corroded, you either can see it, or you have to rely on some other methods, like applying new solder, and you can see this way if the pad does accept new solder. If it does not, it's corroded and you have to scratch it a little so you can break the solder, the corroded layer, and then you will be fine again. As you might can see, we got 2 corroded pads, which I wasn't able to see before I added the new solder. You know, you got 2 arrows here, which indicates pin 1 is here, and I will display GDR6 ball out, and you can see that this pin here is actually an important signal, which is WCK1T. Yeah, and this could be very problematic. So let's try to scratch it. Let's try to scratch it a little and see if we can resurrect it. Yeah, and this pad right next to it, which looks a little bit corroded, is VSS, which is ground, so we don't need to be too careful with that one. Yeah, now let's check if it's actually accepting solder again. Yeah, very well. It's accepting our solder again, and now we can clean the board and retest it. All right, let's go, shall we? I've not told you, but this is my first time resoldering a video memory chip to a graphics card. It will be really fun. I know roughly what I have to do. So I would say let's go. My probe is freaking out again. It got a bad connection on the head. Okay, so let's heat it up. Yeah, and I bought new GDDR6 memory chips from Micron, built in 2020 as it looks, because they start with an O. OQ-A77. Yeah, so they are from late 2020. And we will use one of them. They are already prepared, they are balled. So I noticed in other videos, of course they are using flux before putting the video memory chip on, the solder pads, but they don't use a lot. They use just little. And the reason for that is that you don't want to see your memory chip swim away, you know? It doesn't have to float, it does have to stick. So, where is it? Yeah, let's take some and spread it out nicely. Without having it like too thick, you know. All right, get our hands on the memory chip now. So there's a dot, and there's also those arrows on the PCB. They indicate the very first pin. So yeah, you should align it as good as you can before attempting to resolder it. Well, that's good enough in theory, but I'm not so sure if that's good enough. Okay, that's fine. That looks good. At least to me. Okay, now we are up to 120 degrees C on the board, and now we can apply some heat. Good. I've set the hot jar station to 400 degrees C, and again without any nozzle, and now we can start. So we'll heat up the area a little more evenly with some circular movements, and we should be able to see the video memory chip wiggle into place as soon as the solder was melted. If I have positioned it good enough, it will not wiggle, so I have to poke it. Okay, now it's soldered. I will reflow this one too, just for good measure, because there was so much stress on the PCB. moved slightly, and I think that's enough. So let's cool down the card. Okay, moment of truth. Let's check the resistance of the video memory rail and see if it's shorted. If it's not shorted, we might be good. If it's shorted, I failed. Okay, wow, slightly lower than I expected, but I guess it's still that low because the card is still hot. We are at 73 C. And when I cool it down, blowing some air on it, yeah, the resistance is rising. So this is totally related to the temperature, and I hope I succeeded. So let's further cool down the card, reassemble it, and put it on test bench again. Yes. Okay. It's giving me no errors, so I think it's outputting an image again. Let's run some more tests and then I will try to boot from the graphics card. Nice. So everything works nicely and the GPU is repaired. And lastly, before I finish the video, I want to test if the additional heat during the resoldering, reflowing process damaged or degraded some of the other memory chips, or even the memory chips which stayed in place. Therefore, I used this text command. It's basically overclocking the video memory on the GPU to 120%, so 20% over factory. So running mods with this command will fail, but now the card is on those 120% all the time, so we can run maths now, and we will see the results using 120% of memory overclocking. So it passed, which is a great sign. I mean, 20% overstock is good already, but now I want to find out at which point the video memory fails. And in the end I found that 122% is just over the edge of stability, and some modules start to fail. But interestingly, the three outermost video memory chips which saw the most heat during the reflow and resoldering process are actually the best ones of all those 8 memory chips. So we got 4 failing ones, which are a little bit closer to the GPU core VRMs, which do see a lot of heat, of course, because of the VRMs. But the resoldered and reflowed chips are totally fine. So that proves that for a relatively short time, 250 degrees C, for example, is fine. At least if the card is not running, of course. And the chips do not get hurt from that. Even if you're using a cheap hot air station with 400 degrees C. I know a lot of people say 400 degrees C is too much, but in fact when you are far enough away from the chip, that's totally fine. I mean, the heat drops off quickly. It's not that problematic. Of course, you should not put the nozzle right on the chip. That's clear. So yeah, I think that's enough of details for this video. I think it was already quite a lot for my regular viewers. So I think all I can say now is thanks for watching, and see you in the next one when I test this one as an external GPU for my laptops.